Problem number 5. Okay, so let's take a look. So we got two forces acting on a mass. Okay, so here's the mass. And the first force acting on it at 60 degrees with respect to the negative x-axis. The second force is along the positive x-axis. Okay, so despite these forces, the object remains static. Determine the magnitude of these two forces. All right, so let's take a look. So I got this mass. It's a 150-pound mass. And the first thing I'm going to do is I'm going to place it on the x and y coordinate system. Okay, so we have to do force diagram. So this is something that you guys have to kind of get used to. You got your x-axis, you got your y-axis. And then I'm going to place the forces on it. There is a force acting on it in this direction. I'll make this F1. Here's the angle. All right, so that angle is going to be 60 degrees. Okay, and there's a second force acting on it parallel to the x direction. This is going to be F2. All right, so despite these forces, the object is going to remain static, which means that it's not going to move. So determine the magnitude of these forces. Okay, so the thing which is not very obvious from this one is whether or not the weight matters. So, which means that the weight should matter. So I'm going to place the weight over here because I know it's got mass. So force 1 and force 2 are probably tension forces. So let me just check to see if this comes out of PowerPoint. Okay, so let me check to see if this comes out of PowerPoint. Okay, so we're going to be dealing with equilibrium, which means that the net force is going to be 0 acting on the system. You got gravity pulling it down. You got the normal force. The net force is going to be 0. There's not going to be any acceleration. All right, so this problem looks awfully like this problem. So which means that you got the chandelier hanging from these two cables that you're looking at. And this angle is also 60 degrees. All right, so which is, I think this is the same as the chandelier problem. Okay, so it's going to have some weight. Okay, so now it kind of makes sense. All right, so we got these forces. This thing is going to have weight. Okay, so before we move forward, okay, 150 pounds just converted to kilograms. And give me the answer before we proceed.
$68.18.
68.18 kilograms, right? All right, give yourself 5 points for that one. Okay, so it's good enough. Okay, so what are we looking for? We're looking for these forces. We want to know this and that. All right, so we want to know what F1 is. We also want to know what F2 is. And maybe express them in terms of pounds. Okay, so that's what we want to do. Okay, so what that means is we got two unknowns. If you got two unknowns, you need two equations for two unknowns. All right, so where do you get the equations from? Just sum up all the forces on the x direction. All right, and that's going to be your first equation. So along the x direction, what do we have? You got F2 in this direction, so that's positive. And then you have F1 pointing in the negative x direction, so this one is going to be negative. F1 is going to have an x component in this direction, so F1 times cosine of this angle is going to be the component of F1. It's the x component is going to be the cosine of that angle. All right, so the net force is going to give you the acceleration along the x direction. It's a static system, which means that it's not moving, or which means that there's no acceleration. All right, so because it is static, all right, so it's going to be static because no acceleration. Okay, so it is static. That means there's no acceleration. So what do we have? You have F2 minus F1 times the cosine of the angle. It's going to be 0. All right, so let's just isolate F2. All right, so which means that you have to add F1 to both sides. So F2 is going to be the same as F1 times the cosine of this angle. Okay, so this becomes one equation. I'm going to stop at this point. Okay, so you still have two unknowns. We don't know these two. Okay, so we end up using this equation. So this is our first equation. The second thing is we will do is now we will take a look at the net force on the y direction. All right, so the net force on the y direction, just add them up. Okay, so what do we have on the y direction? This force is going to have a component on the y direction, which is this, which is F1 times the sine of the angle. All right, that's it. F1 times the sine of the angle. All right, so F1 is in the opposite direction. It's got a component. And notice that W is pointing in the downward direction. So W is in the downward direction. And then once again, you have mass times acceleration on the y direction. Once again, it's a static system. Because it's a static system, this will be 0 as well. For exactly the same reason. There's no acceleration. All right, so what do we have? This time, we have F1 times the sine of the angle minus the weight. It's going to be 0. All right, so add W to both sides. So now we got F1 sine of the angle equaling W. That's my equation number 2.
We want to get rid of that sine theta, or we want to keep it.
Okay, I mean, you can do it any way you want. I'm just going to do it my way. Give yourself 5 points because I can't tell you how to do this sort of stuff. The reason why I decided to do it this way, because there's no reason for it. I'm acting on blind faith, basically. And there's something here that I see that I'm going to explore at this point. Okay, here's what I'm seeing. Give yourself 5 points. I mean, you guys feel free to do it any way you want. The only thing I want to see is work, in essence. My way is not the only way you can solve it. What I'm going to do, I'm going to take this and then divide it by this. Okay, so literally that's what I'm going to do. But before I do that, I'm going to change things around. All right, so what I'm going to do, I'm going to change things around, move things around. All right, so I want to get W on the left, F1 sine of the angle on the right. Okay, now I'm happy, I think. This is F1, right? Okay, now I can do something with it. All right, so what I'm going to do is I'll keep this as is and then divide it by this. Okay, so my next step is I'm going to keep this as is. I'll grab this, put it down here. And then I'm going to grab this and place it right underneath. So I'm just going to take the second equation divided by the first one. So this is going to get divided by that. Okay, let me check to see if I can erase this. No, it's not going to let me erase it. So I'm just going to make it a huge equation. I like this. All right. So as soon as I do that, what happens? All right, so notice that F1's right here. We got F1 here. We got F1 here. Cancel. And what else? You know, the sine of the angle divided by the cosine of the angle is going to be the same as the tangent of the angle, right? Okay, notice that I'm about to get a really simple expression, I think. Okay, so just want to add a page. Okay, so it looks like I'm about to get a simple expression. So, which means that this term now becomes this term. So what do I have? So I got W divided by F2 times tangent of the angle. And then I'm going to divide it by this. I'm not going to divide anything. Okay, so I'm just going to switch these sides. In doing so, I come up with this expression. All right, so you know what W is. W is the same as mg. Okay, so I'll do a back substitution. This turned out to be much longer than I wanted to do it, but let's go along. All right, this is as far as we will go with this, I think. Okay, I get a little bit of an OCD. If I don't get a perfect square or rectangle, I'm not happy. Okay, so that's it. So let's stop at this point. Okay, so we got the mass. You know what G is. You know the angle. We got F2, right? So if you have the number, just give me the number for this one at this point. So it's going to be F2. Whatever the number is, just give me the number. Oh, man. Yeah, that was weird. That was an interesting thing I did. Okay, whatever. Okay, so who's got the number? All right, so F2 is going to come out of that one. Where do you get the F1 from? Okay, the F1 is, okay, guys, now that you know F2, you can get F1 from here. That's one way you could do it. Or I can kill myself. Okay, there's something that I missed. And if you know W, which you know W, you can get F1 from here. Another way of doing it is you can get F1 from here and then plug it into this one and you get F2 from there. And all this amazing work that I did was completely unnecessary in reality. Okay, so that's what I mean. It's just, you just goof around with it. Either way, there are a million, I say million ways. There are a couple of ways you can solve this problem. Okay, so it's just play with it. It works out. The only thing that you need to know is, okay, who's got F2? If you have a number, oh, I see the bunch of you guys have a number.
I get 393.6.
Okay, I see a bunch of numbers here. Okay,
Yeah,
so
too.
393.6. Those of you guys who got that, give yourselves 5 points, all of you. Okay, so it's 393.6 is fine. This is newtons, right? Okay, so if
Yes.
you don't mind, just convert it to pounds. Just want to get an idea. So what would this be in terms of pounds? What would this be in terms of pounds? Okay, coloring book.
It should be 86.6 pounds, what I'm getting.
Okay, 86.6 pounds. Let me just check that. Okay, that seems reasonable. The reason is because the main weight is like 150. So this is 86 point what? 86.6. Okay, those of you guys who got that. All right, it's about 87 pounds, right? It's about 87 pounds. Okay, so what should I do? I'm gonna wiggle it. So this is about 87 pounds. Okay, that's good. Okay, so if that's the case, what is F1? Okay, so you can get F1 from here. All right, so this formula should give you F1. All right, so that's the one that we will get to use. All right, so solve for F1. Okay, I think every single person kind of knows how to do this, right? So it's going to be W divided by sine of the angle.
I get 787.
787 newtons or Newton. Okay.
I got 78 points. Sorry, yeah, no, 787.
Okay, so both of you guys give yourselves 5 points for that one. So in terms of, boop, boop, boop. All right, so that I think kind of makes sense because this thing is along the X direction. There's going to be a lot of tension here because of this weight, because it's not angled. Okay. And so what is that in terms of pounds?
173.18.
Yep.
Okay, so it's about 173 pounds. Okay, cool, guys. All right, so now ignoring the details of this, the thing to focus on. Okay, so solving these problems, the trick is the following. Okay, number one, you got two unknowns. You got two unknowns, which means that you need to have two equations. Okay, so here's your equation number one. This is your equation number one. And here's your equation number two. Okay, that's it. That's the solution. Everything else that I did was algebra. Okay, I did it my way. You can do it your way. My way, in this case, wasn't the best way of that thing. Okay, and there was a simpler solution. I wasn't paying attention. You can solve this for F1 and then plug it into that. And that's it, because you know the angle, you know W. And I just decided that, hey, I'm just going to come up with a tangent because evidently I like tangents. All right. So I kind of went off the tangent a little bit unintentionally. All right. So shoot me. I don't care.